Hello everybody. In this video, we are going to discuss about earth dams, different types of earth dams, causes of failure and design considerations of an earth dam. This presentation is prepared by Anise K. Assistant Professor, Department of Civil Engineering, MEA, Engineering, College, Perinthalmanna. An earth or embankment dam is a large artificial dam, typically created by the placement and compaction of a complex semi-plastic mound of various compositions of soil, sand, clay, or rock. It has a semi-pervious waterproof natural covering for its surface and a dense, impervious core. This makes such a dam impervious to surface or seepage erosion. Such a dam is composed of fragmented independent material particles. The friction and interaction of particles binds the particles together into a stable mass, rather than by the use of a cementing substance. Based on the method of construction, earth dams can be classified into two as rolled fill dam and hydraulic fill dam. Rolled fill dams are the type of dams in which successive layers of moistened or damp soils are placed one above the other. Each layer not exceeding 20 cm in thickness is properly consolidated at optimum moisture content maintained by sprinkling water. It is compacted by a mechanical roller and only then the next layer is laid. The suitable materials for rolled fill dams are transported from the borrow pits to the construction site by earth-moving machinery. Based on the mechanical characteristics of earth materials used in making the section of dam, rolled fill dam is further classified into three as homogeneous earthen type, zoned earthen type, diaphragm earthen type. Figure shows homogeneous earthen type dam and zoned earthen type dam. Homogeneous earthen type dam is composed of one kind of material excluding slope protection. The material used must be sufficiently impervious to provide an adequate water barrier, and the slopes must be moderately flat for stability and ease of maintenance. Zoned earthen type dam contains a central impervious core, surrounded by zones of more pervious material, called shells. These pervious zones or shells support and protect the impervious core. Diaphragm earthen type. This type of dam is a modified form of homogeneous dam which is constructed with pervious materials, with a thin impervious diaphragm in the central part to prevent seepage of water. The thin impervious diaphragm may be made of impervious clayey soil, cement concrete, or masonry or any impervious material. The diaphragm can be constructed in the central portion or on the upstream face of the dam. The main difference in zoned and diaphragm type of dams depends on the thickness of the impervious core or diaphragm. The thickness of the diaphragm is not more than 10 m. In hydraulic fill type of dams, the construction, excavation and transportation of the earth are done by hydraulic methods. Outer edges of the embankments are kept slightly higher than the middle portion of each layer. During construction, a mixture of excavated materials in slurry condition is pumped and discharged at the edges. This slurry of excavated materials and water consists of coarse and fine materials. When it is discharged near the outer edges, the coarser materials settle first at the edges, while the finer materials move to the middle and settle there. Fine particles are deposited in the central portion to form a watertight central core. In this method, compaction is not required. Next we will discuss about the causes of failure for earth dams. There are mainly three types of failures, such as hydraulic failure, seepage failure, structural failure. There are four types of hydraulic failures. First one is overtopping. The dam is overtopped when the volume of incoming flow into the reservoir is more than the actual storage capacity of the reservoir, or capacity of spillway is not sufficient. Sometimes, the faulty operation of spillway also leads to the overtopping problem. Similarly, insufficient freeboard or settlement of foundation as well as embankment also cause the overtopping problem in earthen dam. Next type of hydraulic failure is wave erosion. Wave action removes the soil particles from the unprotected part of upstream face of the dam, continuously. This is one of the effective factors to cause the hydraulic type failure in earthen dam. Then another hydraulic failure of earth dam is toe erosion. Toe erosion in the earth-fill dam mainly occurs due to following reasons. Erosion caused by the tailwater. Erosion due to cross currents produced by the storage water, spillway bucket, or from the outlet, create the problem of hydraulic failure. This type of failure can be overcome by providing a thick layer of stone riprap on the downstream face up to the height of tailwater level. Fourth type of hydraulic failure is gullying. Development of gully in earthen dam is the result of heavy downpour which leads to failure of downstream slope. Such type of failures can be eliminated by providing a proper size of berm, turfing or good drainage system towards downstream side of the dam. There are two types of failure under seepage failure of earth dams. First one is piping. The continuous flow of seepage water through the body as well as foundation of the dam is the main reason of piping. It causes catastrophic failures in the earth-fill dams. The flow of seepage water generates an erosive force, which tends to dislodge the soil particles from the dam section. The dislodged particles are migrated into the voids of the filter materials downstream side and thus clog them. As a result, the drainage system gets failed. The seepage flow develops differential pore pressure which tends to lift up the soil mass, causing boiling effect in the dam. Piping also results in the internal erosion of the soil mass due to seepage flow through the earth dam. The pore pressure developed in the soil reduces the soil strength, which makes the soil mass weak, leading to the failure of dam due to shear force. Sometimes, the leakage from earthen dam also generates the piping type failure. The piping type failure is most prominent in those dams, which are poorly constructed. Generally, this is due to poor compaction surrounding the concrete outlets or other parts of the structure, etc. Figures shown here explains how the piping failure occurs in an earthen dam. Another type of seepage type of failure is sloughing. Failure of earthen dam due to sloughing is closely related to the water level in the reservoir. In full reservoir condition, the downstream toe of the dam becomes fully saturated, which is failure by producing a small slump or miniature slide. Under miniature slide, the saturated steep face of the dam is dislodged. This process is continued till the remaining portion of the dam is being very weak to withstand against poor water pressure. Next type of failure is structural failure. It can occur in different ways. Upstream and downstream slope failures due to formation of excessive pore pressure. When a dam is built with relatively impervious compressible soil, the drainage is extremely slow and excess pore pressures develop during and immediately after construction, which leads to slope failure. Upstream slope failure due to sudden drawdown in the reservoir water level. When reservoir is emptied suddenly, then the hydrostatic force acting along the upstream slope at the time of full reservoir is removed without the hydrostatic pressure on the slope to counteract it, which will result in failure of upstream slope. Downstream slope failure at the time of full reservoir. At full reservoir level, the percolation rate will be maximum. The seepage forces will tend to decrease stability. Foundation slide. When the earth dam has foundation of fine silt or soft soil, then it can slide wholly. Failure by spreading. Damaging of dams due to spreading of materials filled above stratified deposits which contains layers of soft clay. Failure of dam due to earthquake. Earthquakes will result in failure of dam through different ways such as cracking of core, settlement, shaking of reservoir leading to waves formation, sliding of natural hills, liquefaction of sand below foundation, etc. Failure of dam due to unprotected side slope. This kind of failure is caused by erosion of protection works provided in the slopes due to the repeated action of waves produced on the surface of reservoir water during the storm. Failure due to damage caused by burrowing animals. Animals may burrow into dam either to make homes or to dig passage from one pond to another, which will result in failure of dams by piping. Failure due to damage caused by water-soluble materials. The leaching of natural deposits of water-soluble materials such as gypsum will lead to leakage, settlement, etc. The diagrams shown here are indicating Various types of structural failures in earthen dam. The essential requirements of the design of an earth dam are safe and stable structure at a minimum construction and maintenance cost. The essential design criteria are: the dam should be safe against overtopping during design flood by providing adequate spillway and outlet capacity. Spillway be of sufficient capacity to pass peak flood by providing adequate spillway and outlet capacity to pass peak flood. The dam should be safe against overtopping by wave action, providing adequate freeboard. Side slope stable during construction and under all conditions of reservoir operation. Upstream slope is safe against rapid drawdown conditions while the downstream slope is safe against sloughing. Side slopes upstream and downstream are flat enough so that the shear stress induced in the foundation is within the shear strength of the material comprising the foundation with a suitable factor of safety. Upstream slope is protected against erosion by wave action while the crest and downstream slope is protected against erosion due to wind and rain. Horizontal berms at suitable intervals in upstream and downstream faces may be provided for this purpose. Downstream slope is safe during steady seepage under full reservoir condition. Portion of the dam downstream of the impervious core is properly drained by the provision of suitable drainage system. Seepage flow through the dam and foundation is so controlled that there is no danger of fine particles getting washed out from the downstream by the efflux of seepage. Moreover, quantity of seepage loss is restricted to the minimum. There is no possibility of free flow of water from upstream through either the dam or the foundation. Adequate impervious core to act as water barrier. Top of impervious core is maintained higher than the maximum reservoir level. Seepage line is well within the downstream face so that no sloughing of the slope takes place. Seepage flow through the embankment, foundation, and abutments is controlled so that no internal erosion takes place. The amount of water lost through seepage must be controlled so that it does not interfere with planned project functions. Transition filters are incorporated to satisfy the two essential conditions of filters, viz., to prevent choking of the filter by soil and have minimum of head loss in the filter. Dam as a whole is earthquake resistant. The seismic conditions of the region investigated with reference to geological map of vicinity. Thank you for watching.